We are starting Unit 4 in algebra. This is all about slopes and graphing. So if we look at the first page, or the second page, welcome to Unit 4. This will be the digital interactive notebook we'll use for this chapter. You'll be responsible for completing the necessary pages in this document and submitting it at the end of the unit. If you are absent, find the video associated with the video for the notes in Google Classroom. Here are some reminders. Some important ones that I always use is Control-C and Control-V, copy and paste. You can also look at these other ones. Those will help you as you move along. Here is our EOC reference chart and then calculator cheat sheet. Here are some reminders on what the different tools in Google Slide helps us with. And we are going to do slide 5 and 6 today, linear functions. So let's look at and try to remember what linear functions are. Will it let you type there? Okay, so you just have to add a text box then. So we need to think back as to what linear functions are. So remember what a function is? X's don't repeat, and it passes the vertical line test. So in order to be a linear function, it has to be a function. And I'm going to put comma in parentheses, X's, X values don't repeat. Zoom in a little bit more. A function, okay, X values don't repeat. A function that forms a line on the coordinate graph. So if it's a linear function, the root of linear is line, linear. So a function that forms a line on the coordinate graph. Okay, let's talk about the characteristics. So we already know one, right? It makes a line. So forms a line. So we need a few more characteristics. When you connect the points, the function is continuous and straight. Another one that we saw in the TEKS that kept on being mentioned was slope and rate of change. To be a line, there'll be a constant rate of change. So just put constant rate of change there. Remember, rise over run as your constant rate of change. And then the equation uses two variables, usually X and Y. But if it's in some kind of situation, it might be two different variables. Do y'all remember y equals mx plus b? That's our general slope-intercept form, y equals mx plus b. And one last thing is the variable x has an exponent of 1. So it can't have an exponent of 2 or 3 or anything like that. It has to have an exponent of 1. There we go. So it forms a line. When you connect the points, the function is continuous and straight, has a constant rate of change. Equation uses two variables, x and y. And we remember the equation as y equals mx plus b. And the variable of x has an exponent of 1. Okay, we are going to find some examples and some non-examples. So over here we are going to use some examples. So I'm going to go and just find go on another tab, and I'm going to search linear function. And go to images. So any one of these that is a straight line can be the image you use. So copy image and then paste it over here. So that's an example of a linear function. This is also an example, so I'm going to copy that. And then I'm going to write an equation just so I have it. Y equals 3x plus 5. That is an example of a linear function because it is just the equation. So I have two graphs and I have an equation. Okay, so let's find some non-examples. Wonder if I can just put non-example. That's a non-linear, right? I'm going to copy that. That's actually quadratic. Okay, let's see what else. This is not linear because look how it says 2x squared minus 3x. Just find different examples of non-linear. Something that does not have a constant rate of change. Okay, so hopefully you have at least two things in there for non-examples. Okay, so let's go to slide 6. We are doing linear and non-linear. So let's look through these examples and decide whether they are linear or nonlinear. Okay, so for the linear and nonlinear card sort, you can actually move the titles around and also the graphs and the tables. So let's look at the graphs first. So let's see. I'm going to move all the nonlinear to the other side. So I'm going to move this nonlinear title over here, and I'm going to move linear over here. I'm going to move it down. So this is an upside down V. That is nonlinear. So move that over. These dots on this one. So if you need to make it bigger, you can. But look at these dots. It also makes a V. That is nonlinear. So move it over to the nonlinear side. Okay, let's see. What about this one? We have 3 dots in a row. Linear or nonlinear? It's linear. We could connect them with a line. Okay, and then this next one. So I'm going to just move these tables all like on top of each other over here. So this is also linear. So now we've got to figure out these tables. How do you determine from a table if it's linear or nonlinear? What do you think? I can't hear you. Okay, but we aren't going to use our calculator. Is that what you're saying? Put it in the calculator? Or what about we graph them? Can we graph them on a grid? Or the other thing was a constant rate of change. How can you determine if it's a constant rate of change? It has to have the same rate going from y, each one of the y's, and then each one of the x's. So let's say we look at this one. What is the rate of change on the y's? 5 to 10. How much did it go up? By 5. Okay, and then from 10 to 20, it went up by 10. But then our x, how much did our x go up by? 4. How much did our x go up by from 6 to 14?
8.
So the y's went up by 5, and then it doubled to go to 10, and then the x went 4, and then it doubled to 8. This is linear because it has the same change of y over change of x. It's going in the same pattern. So that is linear. These are a little tricky to do. We could also graph them. So let's see. Let's do this next one. 0, 1, 2, 11, 3, 17, 5, 26. So going on the y side, going from 1 to 11, how much did that go up by? 10. And then from 11 to 17, how much did that go up by? 6. And then 17 to 26, what did that go up by? 9? 9. Okay, so we have 10, 6, 9. And then the x's went up by 2, and then 1, and then 2 again. Did it follow the same pattern? No, because that was 10, 6, 9. This was 2, 1, 2. So the ones that went up by 2 should have the exact same increase, but it was 10 and 9. So this is nonlinear. Okay, let's look at this one. From 7 to 10, how much did that go up by? 3. From 10 to 13, 13 to 16. Okay, so all the y's went up by 3. What did all the x's go up by?
2.
Yep, 13 to 15 is 2. 15 to 17, 2. 17, 19, 2. So it followed the same pattern. Okay. Now our last one. 1 to 4. How much did that go up by? 3. 4 to 16. 12. 16 to 64. Oh, what is that? Like 40 something? 48? If you subtract them. Right? Okay, and then the x's, this went up by 1, but then this went up by 2. If it goes up by 1 here, and that one only goes up by 3, then if it was linear, you would double the 3, which would be 6. So 4 plus 6 should get you 12. 10? So this is nonlinear. It's not following the same pattern. Okay, so we have finished linear versus nonlinear. Okay, so you have to have a constant rate of change, has to form a line. Okay, we are done with our digital notebook. What you're going to do now is your Unit 4 divider, and you're going to do the vocab on there. The vocab should be on a Quizlet, and I don't see it yet, but I will share that with you, and you will go on Quizlet. Let's see, finding slope and graphing linear functions. So I will copy this link over to Google Classroom for you.